On Friday, we talked about graphing quadratic equations. Today, I would like to look at taking an equation that is in vertex form and converting it into, taking an equation that is in standard form and converting it into vertex form. And then we can talk about some different strategies to graph this as easily as possible. So I did recall the steps that we wrote down when we were looking at vertex form, or when we were looking at completing the square from a few days ago. Just to kind of recall a few of those, we want to start by adding and subtracting the constant to the other side of the equation. So if we look at example 3, my first step might be subtracting 1 from each side and just moving it over to the other side. Now notice that there is still a y there, because at this point we are just simply rewriting it into another form. We're not actually solving for x or anything at this point. So I'm going to subtract the constant from the other side. It does talk about if there is an a value, we do want to also factor that a value out. So since there is an a value of 2, I'm going to factor that out, 2x squared plus 2x, and then kind of leave in that blank for us to be able to complete the square. When we complete the square, remember we'll look at the b value. We'll take that b value, divide it by 2, and square that. 2 divided by 2 is 1. 1 squared is 1. That's what we're going to be putting here to complete the square. And then, of course, we need to add to the other side. Now, when we add to the other side, remember that this value, if there was a GCF that was factored out, we need to multiply those together, and then we need to actually add 2, change that color, sorry. We want to actually add 2 to the other side. So we are trying to keep that balance on both sides of the equation. That'll give us y plus 1 on this side. When I add the negative 1 and the positive 2, I'm going to get positive 1. On the other side, I have the 2 factored out, and then I have this trinomial. And recall that that trinomial will always factor into a binomial squared. In this case, it's going to be x plus, we use the same sign as the middle term in the trinomial, and then it's going to be x plus 1. 1 is the square root of this c value. It's also half of this b value. Then our final step would be to take the 1 from the other side and subtract it to bring it back over to this side, giving us an equation that now looks like this. Y equals 2 times x plus 1 squared minus 1. That's my equation in vertex form. So we now have two equations. Well, they're the same equation, but we have them written in two different forms, standard form and vertex form. And then with those two equations, we can look at some different methods of being able to graph them. For example, we know that in both cases, the a value is this positive 2. Because the a value is positive, we know that this graph is going to open. I keep using that highlighter. We know that this graph is going to open up. And because we know that this graph is going to be opening up, we know that there is the vertex is going to be the lowest point, which means that the vertex will be a minimum value. Because we have it already in vertex form, we can find the vertex by looking at the h and the k value. Remember that we want the opposite of that h value. So whatever's in the parentheses, we do the opposite. But we're going to keep the k value as is. So my vertex is negative 1, 1. The axis of symmetry is going to be that vertical line that goes through the vertex. And because it's a vertical line, it's always going to start with x equals. And because it goes through the vertex, we're always going to use the x value of the vertex. So now we have at least one point to plot, negative 1, 1. If I zoom in a little bit, we can plot that point here. But we obviously need more than just one plot to graph. So now we have a couple of choices to make. One, we can go back up to either one of the forms, and we could find the y-intercept. Now keep in mind that when finding the y-intercept, we are going to plug in 0 for x, and we're going to solve for y. The easiest thing to do would be plugging it into the standard form. If I plug it into standard form, when I plug in 0 to the 2x squared, that becomes 0. The 4x becomes 0, and that leaves me with just 1. So now I have another point that I can plot. 0, 1 is my y-intercept, 0, 1 right here. At this point, I can decide, do I want to find the x-intercepts? We talked about finding the x-intercepts on Friday. Or do I want to just plug in some other values into the table? Now, a third option that we didn't talk about on Friday is the axis of symmetry. Since we know that the axis of symmetry is the vertical line that goes through the vertex, and we know that the axis of symmetry means that the graph is symmetric, the parabola is symmetric, meaning it matches, it's the same on both sides. If we have a y-intercept on one side, we could plot a matching point on the other side, and then we could use these 3 points to be able to graph our parabola. So in looking at a couple of different strategies, we have options of finding the y-intercept and using symmetry. We can find x-intercepts. We obviously need to find the vertex, but we have a variety of strategies that we can use now to be able to graph these. The domain for this one is, again, going to be all real numbers, negative infinity to infinity. And our range is going to be from -1, that would be the minimum y value, up to infinity. So that gives us an example of going from standard form into vertex form and then graphing from that. I do want to do a second example, just looking at number 4, of rewriting it into vertex form. So one more time, we're going to go through these, one more time, we're going to go through these steps that we had talked about previously, and just do it one more time to make sure we understand this process. So once again, if you take a look at those steps, my first step in completing the square is to add or subtract the constant to the other side. So in this case, I'm going to add the 7, and I'm going to add that to this side as well. Keep in mind, there's still a y over here, so I'll just write it as y plus 7. And on this side, I have the x squared plus 4x. Now, there is no a value to factor out, so I don't have to worry about step 2. That one's done. But I do want to move on to step 3, which is to complete the square. So we're going to be adding something to this side. We're going to look at the b value of 4, divide that by 2, square that. That's what we're going to be adding. So 4 divided by 2 is 2, and 2 squared is 4. I'm going to be adding the 4 to this side. Since there is no number factored out, whatever we added to this side, that's what we're going to turn around and add to the other side. So I'm going to be adding 4 to this side as well, which means that I now have y plus 11 equals, and now my trinomial is going to get factored. This always becomes that binomial squared. It's going to be x plus, I'm using the plus because it's the same sign as the middle term. And then the square root of 4, or half of 4, is 2. That's what goes inside my my binomial. And then finally, I'm going to subtract that 11 to bring it back over to the other side, which means my equation in vertex form says y equals x plus 2 squared minus 11. And again, in terms of the graphing, I now can use a variety of strategies. Because my a value here is just 1, and we can see that both in the vertex form and in the standard form. Since the a value is positive, we know this opens up. Since it opens up, we know that there is a minimum value, so my vertex is going to be at a minimum. Again, to find my vertex, since it's in standard form, I can use the opposite of that 2, so -2, and the -11, there's my vertex. My axis of symmetry is going to be the vertical line going through the vertex, so that's x equals -2. And I can start looking at how I want to graph this one. Now, with a vertex at -211, I might have to estimate where that goes. -11, excuse me, that's just going to be just off the graph. If I look back at the standard form, if I plug in 0 for x and solve for y, that should give me a y-intercept. And again, looking at your standard form is your easiest. The x squared becomes 0, the 4x becomes 0, and that means my y-intercept is -7. So if I plot that point, that's right about here. And again, remember, I can use my symmetry. Since I know the axis of symmetry is this x equals 2, I can plot a point over Notice that my y-intercept is 2 places away from that axis of symmetry. So if I go 2 places away on the other side and plot another point, that gives me a second point to be able to graph my parabola. Now again, we did talk about finding x-intercepts. We could go back up to the original equations and find x-intercepts. We could plug values into our table. So we could pick one number on each side of the vertex, say -1 and -3, for example, and plug those into the equation and plot those points. So we do have a variety of strategies. And as we talk about these strategies, that's one of the things I want you to be working on today, is looking at equations that are written in different forms and deciding which strategy is the best to be able to graph those. So if we look real quick at just maybe 1 or 2 more, if we look at example 5, we need to decide, currently it is in standard form. We need to decide if we're going to rewrite it into vertex form, if we're going to leave it in this form. If we do leave it in this form, what is the best method of being able to graph this? Now, one of the things I noticed right away is that my a value is negative. If I was to factor that negative out, so factor out a -1, that would leave me with this. And then hopefully you will recognize that that is a difference of squares, and that can be factored into -1. Sorry, the pen doesn't seem to be working here. X -1 and x plus 1. Now, the advantage of rewriting this into factored form is that in the factored form, now I could very quickly find my x-intercepts. If I plug in 0 for y and solve this equation, x -1, x plus 1, and remember I can solve this equation by setting each of those equal to 0. X -1 equals 0 gives me a value of 1. And x plus 1 equals 0 gives me an x value of -1. What I've just found here are my x-intercepts. When x is 1, y is 0. When x is -1, y is 0. I now have 2 points that I can plot on my graph. An x-intercept of -1 and an x-intercept of +1. And then let's see, if we look back at the equation in standard form, since my a value is negative, I know that this parabola opens down this time. And because it opens down, I know that there's going to be a maximum point. And of course, I do want to find that vertex point. Now remember, since I never took the time to write it in in vertex form, I'm going to have to find my vertex by looking at the standard form. And when you're finding your vertex in standard form, you're going to do -b/2a to get the x value. So in this case, there is no b value. Remember that the b value is always with the x, and there is no x term. So in this particular case, my b value would be 0. My a value is -1, but 0 divided by anything is just 0. So I know that the x value of my vertex is at 0. If I plug that 0 into the equation, y equals -0 squared plus 1, I get a y value of 1. So my vertex is at 0, 1. If I plot that point, we're here. We already know it opens down, and we already have x-intercepts on either side of that. So we now have enough information to be able to graph this parabola. Axis of symmetry, remember, is the vertical line going through the vertex. Since the vertex is at 0, the axis of symmetry is just going to be at x equals 0. And once again, the domain on this one is all real numbers, -∞ to infinity. My range is from -∞ up to that +1. And remember that +1 was the maximum value.